Have you ever wondered how a file sitting on your screen physically breaks down, travels thousands of miles across the globe, and reassembles flawlessly on another machine? This diagram shows the structural map that makes that journey possible. It is called the TCP/IP protocol suite, and it operates like a strictly orchestrated relay race for data. To understand how this works, we will trace a file's journey top-down through these four specific layers. We start at the software level with the application layer, move down through transport and network, and finally end up at the physical cables. Networking requires a rigid, step-by-step packaging process. Long before a single piece of data ever touches a copper wire, it has to be wrapped and labeled in a specific order. This zoomed-in diagram shows the top of the stack, the application layer. It establishes the rules of conversation between software programs. Different tasks require specific protocols, like HTTP for web browsing or SMTP for email. For our file transfer, the system uses FTP, File Transfer Protocol, communicating specifically over ports 20 and 21. This split-screen diagram illustrates the two middle layers. It is easy to confuse the routing logic of the transport layer on the left with the network layer on the right, so let's separate them. We look at the network layer first. Driven by the Internet Protocol, or IP, it handles host-to-host delivery. It uses logical IP addresses to navigate the network map, much like a delivery truck driving through city streets to find the correct destination building. Once the truck arrives at the building, the transport layer takes over for process-to-process delivery. Using protocols like TCP, it finds the exact apartment door, the running software program identified by a port number, and verifies that the package arrived without errors. Without both layers working together, a packet might successfully reach the right hardware, but the operating system wouldn't know which software application should actually open it. This diagram shows our fully packaged data finally reaching the bottom, the physical layer. Here, the logical routing instructions are stripped of all interpretation, leaving nothing but pure binary bits. The physical layer has a single function. It must encode those ones and zeros into physical signals so they can travel across actual infrastructure. Those signals take different forms depending on the transmission medium. Guided copper cables carry electrical waves, fiber optics use flashing pulses of light, and unguided wireless routers or satellites broadcast radio waves. Let's test your understanding. This diagram shows our physical electrical signal crossing the globe and striking the hardware of the receiving server. Pause the video. Write down the sequence of layers this receiving computer must use to open the file, and name at least one protocol it will encounter on the way. Mastering network architecture requires seeing the symmetry in the system. Every packaging action by the sender requires an equal and opposite unwrapping reaction by the receiver. This diagram shows the solution. Receivers read data from the bottom up. The signal hits the physical layer first, where it is instantly decoded back into a sequence of binary zeros and ones. The data begins its upward climb. It enters the network layer, which verifies the destination IP address. Then it moves into the transport layer, which checks the TCP port to route the data to the correct process. Finally, it reaches the application layer. The file transfer protocol unwraps the last layer of messaging, perfectly reassembling the original file on the server. This rigid, symmetrical climb ensures that completely different operating systems and devices across the globe can communicate with total precision. This grid shows your master cheat sheet for the entire stack. From application software messages, down through transport's process delivery, and network's host routing, straight to physical's physical signals. Take a screenshot of this grid and use it as a permanent study aid. Because every device on the internet follows the same four-layer logic, your data can travel from a laptop to a server halfway across the world and arrive exactly as it was sent.